C99 tutorial part 11. In the last few lessons we've been looking at the getChar function in order to get input from the user, as well as while loops, for loops, and arrays. So for this tutorial let's look at a couple of example programs. The reference that I'm using is Kernighan and Ritchie section 1.6. So the first program to do is to make a histogram of the input. We're going to read words in and make a histogram of the lengths of the words in the input. So just an example, if we read in some input like this, hello, this is a sentence. So we should count the words. This is 5 characters, 4 characters, 2 characters, 1 character, and how many characters? 3, 4, 5, 6, 7, 8 characters. And so we should make a histogram something like this. 1, 2, 3, 4, 5, 6, 7, 8. We have one word, which is 1 character. One word, which is 2 characters. One word, which is 4 characters. One word, which is 5 characters. And one word, which is 8 characters. So of course, as the input gets longer, this should hopefully look more interesting. So one thing to notice, this program is similar to the word counting program, so let's use the word counting program as a basis. So let's go to our chapter 1 directory. And inside here we have, where is it? Here's the WC, the word counting program. So in this program we look through the input in our getChar loop, and we're continuously counting up the number of words using this NC counter. So one idea would be, let's create a copy of this program and use it as a basis for our histogram program. I'm calling this histo wordlen because we're making a histogram from the word lengths of the words. Right, so first of all, let me rename the program. We have here WC is the old name, so I'll call the new name histo wordlen. Replace. Okay, good. Now in the word counting program, we're counting several things: number of lines, number of words, and number of characters. But actually, in this program, we don't need to do that. We just need the word counting. Or in fact, actually, we don't even need to count the number of words. What we actually need to count is the word length. So let's instead use the word length. So each time we go through the loop, we need to increase the word length counter. Number of lines, we don't need this anymore. This one we still need because we need to know whether we're inside a word or outside a word. And recall the way this logic works. This first if statement says if the character is a white space character. So if it's space, new line, or tab, then we know we're not inside a word. On the other hand, if it's any other character, then we know we are inside a word. So we changed inside word from false to true. So this is where the word counting is happening. So why don't we change this, and since we're not counting words anymore, we're instead counting the word length. This is the moment where we recognize a word. So let's, just for demonstration purposes, let's print out the word length. Here's the word length, and then at the end of this we need to also reset the counter, because at this point we've noticed a word, we print its length, and then reset the counter. So if the logic is correct, this should print the length of each word, and actually at the end I don't need this anymore, and yeah, each time there's a word, it should print the length of the word. So we're going to make this program in stages. First, let's print the length of the words and make sure that works. recompile the program. Make sure there are no errors. Okay, good. Histo wordlen. Type in a word like hello. Wordlen is 1. So something's obviously wrong. Let's take a look at it again. Notice how this works. At the very beginning we have inside word as false. So we assume we're not inside a word. And on the very first character that is not a white space, then we make here a transition. So right on the H, imagine you type in hello. So we get to the H. And what do we see? It's inside word is false. So the first thing we do is set inside word to true. And then print the word length. And of course at this point the word length should be 1 because initially it was 0, we found the H, and then we print a 1, and then afterwards we reset the counter. So I think this logic should actually be moved into the other loop, because at this point we have discovered the end of a word. So let's try it this way. Don't forget to add the brackets here, the curly braces, because now we're doing multiple actions inside the for loop. Inside the if statement, that is. And one more fix we can do here, this statement here to reset the counter would make more sense here, because at this point we have discovered a new word. So this says if the inside word is currently false, then we're going to set it to true. And at that moment we'll reset the counter. So that way each time we find a new word we reset the counter, and each time we leave a word we print out the counter. By the way, you can exit a program if you press Ctrl-C. This breaks the program. So I press Ctrl-C now. Let's recompile. Histo wordlen. Hello. So now I have 5, which is good. Try something else. 9, okay. What if I type just 1 character? It's 1. What happens if I just press enter? Then I get 2. Okay. Well, that doesn't seem right. So it seems to work if I type in a small word, but if I just press enter alone, then I get something not expected. So let's go and take a look at that. So here's what's happening. Notice this part of the if statement. If it's a white space, then first we reset inside word to false and then print the word length. But at no point do we reset the word length. The word length is only reset when we find a new word. And actually that's okay. We can that logic works. The only problem here is that we're printing the word length even when we're not inside a word. So when I press enter several times, we're printing out a value that is really not helpful. So one way to fix that is like following. Let's do similar to how we did in this statement and say we're going to print out the word length only if we were already inside a word. So if inside word, then print the word length. And this test should be done before we reset it, otherwise it will always be false. So now it looks like this. So we come in we see a white space, and we're going to print the word length only if we were already inside a word. And then we reset it to false, because you know when you see a white space you're no longer in a word. So try this one again. Cancel, recompile, and run it again. Hello. Press enter. So now when I press enter, I get nothing. So it's not telling me the word length because it doesn't see any word yet. Okay, so it seems to be working. We solved the first part of the problem. The second part is to use an array to store the number of words that have a certain length. In other words, we need an array. So let's make an array right now let's call it counts, and let's have, I don't know, let's say 15 members. So with 15 members, let's initialize them to 0. Remember that this notation will initialize element 0 to the value 0. If we continue typing values, then each one initializes the next value. So this would initialize counts subscript 1 to 0, counts 2 to 0, counts 3, and so on. But it turns out that if we specify just one initializer, or if we leave off some, okay, for example, this array has 15 members, and here we've only specified 4 of them. So the way it works is the members that we don't specify are assumed to be 0. So we can just write this. This means that the compiler will initialize the other ones to 0 for us. But be careful, if you don't give any initializer, like if you do this, then the compiler doesn't initialize them and their contents are undefined, which means maybe they could have random values in there. So you always want to initialize the array before you read from it. So let's do it this way. Right, moving on. So notice at this point is where we discover a word and we also know how long it is. So this is the same point where we should update our counts. So let's use the counts variable, the counts array, like follows. If we discover a word which has a length of 1, then we'll use counts 1 to store that. As an example, we increment counts 1 by 1. So in general, it should be like this. We use the word length that we discover as the index. So if the word length is 12, then we'll increment counts 12. The only problem is, if you recall, an array, as we have now, counts 15, has the following elements: counts 0, counts 1, and all the way to counts 14. So the indices always go from 0 to 1 less than the size. So we need to make sure that we don't go over that amount, because the C compiler won't check that for us. So the way to do that is we use an if statement here. If wordlen is less than 15, then we increment the counter. And then you can decide what to do if it's too big. If you have too long of a word, then I suppose we can have a different counter for counts big, for example. So this will count all the words that are too big to fit in our array. And for that count, we just need one integer, counts big. One more thing is this statement here. This is a type of debugging statement. We just used it in the first stage to make sure that we're counting the words correctly, but now we can comment it out because I think we're pretty sure that it works properly. One more improvement we can do is to replace this number 15 with a pound define. So let's write the word max here, and then we use pound define max 15. That way, if we decide we want more later, we can easily change it at the top of the program. Okay, so I think this should work. Now all we need to do is at the end of our input loop, we need to print out the histogram.